The second of this series of videos where I'm taking as an example negating an expression. Okay. This video is one goal only, which is to clean up a bit of weirdness. The weirdness is that if we look at an implication is treated as a for all, and that is converted into a there exists. So you end up with something like this: for all n is greater than 0 implies n is not n plus 1, says there exists n and there exists a proof that n is greater than 0 such that not n is not n plus 1. Okay. We really don't want to do this. I mean, what we want to say is for all there exists n such that n is greater than 0 and not n is not n plus 1. Okay, so we want to convert the negation of implication to and rather than exists, because the proof doesn't matter. We want to say something is true rather than there exists a proof of it. Okay, so what we do is we have to modify this in the special case where domain is a proposition. Fortunately, we have a method which checks that up. We want to modify the whole body in that case. So if is prop the domain, then we'll do something, and else we'll be back to what we do. Well, what do we do here? It's actually quite simple. We'll make app m and, so not add, but and we'll give it two parameters. Okay, the first one is just the domain, and the second one is the negation of the body. So there's no need to define another variable for that. Negates the body. Okay. So we are, if in the case of a proposition we are doing this. Let's check if this worked, and then we'll slightly refine it after this. Okay, so now what happens is for all n is greater than 0 implies n is not n plus 1. The negation of that changes to there exists n such that the hypothesis is true and the conclusion is false, which is what we want to do in real mathematics. Yeah. There is a small twist here. So this will work in almost all normal code, but sometimes when you have code generated by tactics, complicated tactics and so on, the body might as an expression include the variable, even though up to definition and so on it should not depend on the variable, in which case you'll get a low level error because this body will have a bound variable in it. Okay, so that is easily handled. What we do is that we still have a local declaration. Okay, so we'll have and we will still instantiate the body. Okay, so let's go here and we say even in this case we'll have a low level we'll have a local declaration. It will introduce a variable x, and if the body depends a priori on the meta variable 0, which corresponds to the variable for the given domain, we'll instantiate it. This has not affected here, as it should not. It should not work in have any difference in most cases, but in strange cases it will make things correct where you would have a low level error otherwise. Okay. So this was one special case we had to deal with before our last main case, for which we'll look at the third video, and in that is to deal with the exists case. So what we have done is we have negated for all and made it there exists in these two videos, taking care also of a corner case where you had an implication being viewed as a for all.